Okay, good evening all of you. So let's start with the motion curves, okay? In rectilinear motion, okay? See, as the name indicates, motion curves, okay? So here we are going to consider the graphical solution, okay? We are going for graphical solutions. Whatever problems we have solved, okay, we can solve it by graphical method, okay? Means we can analyze the motion parameters, let's say displacement, velocity, acceleration, all we can what analyze graphically, and for that we will need a motion curves. Okay, so what is motion curve? Actually, motion curve is nothing but a graphical representation. What? Graphical representation. Graphical representation of what? Graphical representation of the variation of what? Variation of the motion parameters. Today we'll discuss about the basic concepts only. Okay, next time we will start with the numericals. Okay, so that you will be familiar with all the basic concept. Okay, because इसमें जो है confusion रहेगा तो आगे के lectures कुछ भी समझ में नहीं आएंगे, इसलिए आज का basic आपको समझ में अच्छे से आना चाहिए. Okay, now the motion parameters means acceleration, displacement and velocity. Okay, right. Now see here what I have written. These two words are very important. Graphical representations of variation. Variation means, you know, what does mean variation? Variation means what? How it is varying, na? Suppose मैंने अगर acceleration लिया, graph, you know ना? You know the graph is plotted between the two coordinates. One is x and one is y, right? So one is here what? One is called dependent variable and another is a independent variable. Okay. So let's say if I have y is equal to fx. Okay. Am I clear? Hello.
Yes, sir.
हाँ.
Yes, sir.
Audible हूँ ना मैं? Hello.
Yes, sir.
हाँ, अगर
Yes,
कुछ
sir.
भी अगर कुछ भी इशू आया तो बोलो. हाँ, ठीक है. तो y is equal to fx. Okay. Here you can say y is what? जैसे जैसे हम लोग यहाँ पे देखो, you can see here as I will change this value of x, what will happen? This y will change. Okay, means this y is what? Dependent on this x, but this x is not dependent on this y. That's why I can call it as an independent variable. Okay, तो independent variable होता है एक और एक dependent variable होता है. The relationship between dependent and independent variable is shown on the graph. Okay, so that means we need two coordinates here. So variations, if I will talk about, the variation is always with respect to some other independent parameter, and that we are going to call it here as a time. What? We are going to call it here as a time. Are you getting me? So now you can read this definition. Graphical representation of variations of motion parameters, and motion parameters is going to remain same, that is acceleration, displacement, velocity. ये तीनों में से कोई भी एक रहेगा. Okay, with respect to what? Time, right? Na? So that means your this x-axis will always be time. Are you getting me? Your x-axis will always be time. Now the y-axis may be acceleration, maybe velocity, maybe displacement. So if this variation is considered between acceleration and time, this is called as a AT curve. What? This is called as a AT curve. If this is considered between velocity and time, it is called as a VT curve. Okay. If this is considered as between S and T, this is called ST curve. Okay. So three common types of motion curves which are commonly used are ST curve, VT curve, and AT curve. Right. So in ST curve, your ordinate will represents displacement and abscissa will be time. Abscissa in all the three cases will be time. Okay, time is an independent parameters. So as the time will change, as the time will proceed, how the motion is changing, okay, how the motion is changing, that we can predict here, okay, with respect to the graphs. Is that clear? Hello? That is what?
Yes, sir.
Motion
Yes, sir.
curves. Now the nature of this motion curves may be anything. Okay, this nature of the motion curves may be linear, okay, may be constant, may be parabolic, okay, maybe cubic, maybe anything, okay, etc. With this particular nature of this curves, we will come to know some conclusions, and that we are going to do everything here. Okay, everything we are going to study here. How this nature can be how this nature can be interpreted, and how these parameters we can calculate. Okay, if and also we are going to see if we know ST curve, how to get VT curve. If we know VT curve, how to get AT curve. We are going to see how to get VT curve from AT curve. Okay, we are going to see everything. Means we are going to see the straight method as well as reverse method. मतलब हमारे पास ST है तो VT निकालना क्या होता है is a very obvious. Just a moment. Yeah, you all know, since what velocity is what ds by dt, right? And acceleration is what dv by dt, right? So you know that if you know the ST curve, you can get the VT curve. Okay, and from VT curve, you can get the AT curve. This process we can apply through this, we can get through the differentiation process. Right now, is it clear? This is very clear.
Yes, sir.
Then second thing, you also know reverse method. अगर आपके पास AT है तो you can get the VT. From VT you can get the ST. This you can get through integration. Am I correct? This you can get through integrations. Okay. तो ये इस तरीके से है और ये इस तरीके से है. Okay. For example, let's say अगर मेरे पास मेरे पास S is equal to कुछ equations है. Let's say 3t square. Okay. Let's say 3t square is there. Okay. Or you can say 3t cube. Let's say. Okay. 3t cube. So we will be what? ds by dt. What I will get here? Can you tell? 9t square. Am I correct?
Yes.
What I will get? A I know that is dv by dt. That is d2 2, and that I will get 18 into t. Okay. Am I clear?
Yes,
Can
sir.
you see here? Again, if I consider some examples, let's say t square. S is equal to t square, let's say. So what I can get? V as what? 2t. Simply. A as 2. Am I correct? तो if you observe here carefully, अगर ध्यान से देखो यहाँ पे, तो t यहाँ पे t का power is what? 3. Then here the t का power is 2. Here the t का power is what? What? 1. Am I correct? This power goes on reducing, right? Again here you can see this is 2, this is 1, this is 0. Am I correct? That means if I have s is equal to f of t, okay, some polynomial of degree n, I can say, okay, I can say the velocity will be a polynomial of degree n minus 1, and acceleration will have a what polynomial of degree n minus 2. Can I conclude here? Hello?
Yes, sir.
Yes, sir.
This you have to keep in mind. Okay, this will help us to draw the motion graphs. This will help us to deal with the motion graphs when we will actually solve the problems. Okay, I will come to this point when I will predict the nature of the graphs. Okay, so right now I am leaving this point here itself. Okay, now next thing, let us start one by one. First, we will start with the ST curve. So let me draw the diagram first. स्क्रीन दिख रहा है ना सबको?
हाँ सर.
Yes, sir.
हाँ. Okay. तो लेट्स से ST ग्राफ पे मैं देता हूँ, ठीक है? ST, or you can also call this as a XT graph. Okay. So as the name indicates, XT graph. So as usual, मैंने बताया आपको already, the x-axis will represent your time axis, okay, and y-axis will represent your s, that is displacement, that is s and t, correct? Now let's say any curve, any random curve I am taking, okay, let's say, okay. Now let's say two intervals, okay, any two intervals in between this, okay. Let's say this is T1, this is 0, starting from west, this is T2. After some time T2, or you can say this is final interval T3, and in between them there is a second interval, that is T2, okay, right? So finally the particle is here, okay, T3, started from west, at T1 it is here, okay, at T2 it is here, and T3 पे यहाँ पे है, ठीक है? Am I clear to you? Hello?
Yes, sir.
Yes, sir.
Now,
Yes, sir.
now you know that, okay, one by one we will see the use of each graphs, okay. So ST graph is used for what? Now see, if you know the velocity is what? ds by dt, right? ds by dt. Here s represents y coordinates. That means it is nothing but in the form of dy by dx, because your x-axis is time axis, y-axis is s-axis, right? So it is nothing but slope, right? Now I can say this is what? Slope. That is tan of theta, correct? Tan of theta. So here I can say that slope of this ST curve, if I will consider the slope of this ST curve, is nothing but velocity. Can I say hello?
Yes, sir.
Slope of this ST curve will give me the velocity. Okay, velocity. Slope of this ST curve will give me the velocity. This is first thing to note here. So how I can mark the slope here? Slope is marked as just by drawing the tangent to the lines. Okay, curve, tangent to the curve. तो यहाँ पे अगर मैं देखूँ तो इसका टेंजेंट जो है इस वाले पॉइंट पे, ये वाला टेंजेंट अगर मैं देखूँ तो this is one tangent. At this point I can get this velocity. Okay, right? Here it will be s. Okay, I can get some value of s here. Okay, this will be my v here. I can get the v, okay, just by calculating. Okay, v is what? V is nothing but s2 minus s1 by t2 minus t1. That is the slope, right? So if I consider this point, okay, what I can find here is this line, this tangent. Okay, if you consider this tangent here, this tangent, okay, this tangent indicates some value of theta, okay, and that theta will represents the increasing slope or decreasing slope. तो यहाँ पे ये tangent अगर मैं देखूं तो by looking this figure I can say whether the velocity will be positive or negative. Can you tell me? Hello. Similarly, if I will consider this point, I will have tangent like this. Okay, this will be my v here, ds by dt. And if I consider this my tangent here, so this will be the v3. Okay, here it is v1. Let's say here it is v2. Here it is v3. Okay, so ds by dt at t is equal to t3. Okay, and this will be t is equal to t2. तो यहाँ पे आप 3 सेगमेंट्स देख सकते हो. पहला वाला ऐसा है, दूसरा वाला ऐसा है, और थर्ड वाला ऐसा है. Am I clear? हेलो हेलो.
Yes, sir.
Yes, sir.
हाँ, जाग रहे हो कि
Yes,
सो गए
sir.
सब लोग?
नहीं, sir,
जाग रहे हैं,
अभी
sir.
clear.
हाँ, रिप्लाई
जाग
नहीं
रहे
आ रहा है ना.
जाग रहे हैं सब।
Yes,
माइक
sir.
अनम्यूट
बोलते
होने
रहेगा.
फिलहाल तो जाग रहे हैं।
माइक
हाँ,
अनम्यूट
ठीक
होने
है,
में टाइम
देखो.
लगता है.
ओके, सो सी, अगर मैं ये वाला कंसीडर करूँ यहाँ पे, ये पहला वाला सेगमेंट, तो यू कैन सी दिस. ओके, दिस लाइन. नाउ यू नो दैट. ओके, इफ आई एक्सटेंड दिस, you know that. Yeah, एक मिनट, just a moment. if you consider this, okay, you know that this, okay, this is what, this slope theta, it is measured anti-clockwise now, always with the positive x-axis. So you can see here theta is always representing an acute value, है ना, in the first region of the time interval, that is 0 to t. तो 0 to t interval में हमेशा जो है वो values acute angle आएगा theta, and it is what, it is what, acute, right ना. और जैसे जैसे आप देखो आगे बढ़ोगे, ये थीटा का वैल्यू क्या है, सेम रहते जाएगा, राइट ना. दिस मीन्स हियर द वेलोसिटी इतना तो श्योर है कि वेलोसिटी विल बी व्हाट, पॉजिटिव, राइट. एट द सेम टाइम ये वाले पॉइंट पे जब आओगे तो वेलोसिटी विल बी व्हाट, देयर विल नॉट बी एनी स्लोप, करेक्ट, बिकॉज इट इज व्हाट, straight line will give you the zero angle means tan 0 is 0, there will not be any slope, so at this point you will get zero velocity. Similarly here, if you consider here this point, okay, and if you measure the theta anti-clockwise, this will get a obtuse angle, right now. This obtuse angle, let's say theta more than 90 degrees, let's say tan of what, 120 degree, okay, so it will be minus something √3 or something, so you will get here the negative value. That means this segment, okay, at this point t3 you will get negative velocity. So are you getting me what I mean to convey you here? ST graph is what exactly giving you the what picture of the velocity at various time instant, okay. That means using this ST curve you can directly calculate the velocity at an instant, okay. And you can also say at the point where the velocity changes its direction is this point, okay. वहां पे आप क्या करते थे, कैलकुलेट करते थे v को 0 से इक्वेट करके, यहाँ से डायरेक्टली आप ग्राफ से ये पॉइंट लोकेट करके फाइंड आउट कर सकते हो, देखो, राइट ना. So here is, this is the point that is let's say p is the point where the velocity changes its direction, and slope of this xt diagram is what, 0, correct. So I hope this st diagram is clear to you. So st diagram का क्या काम है, st diagram will always give you the slope of this st diagram will always give you the velocity, okay. ठीक है. Hello.
Yes, sir.
Now next, एक मिनट.
सर इसका एरिया का भी आता है ना कुछ,
हाँ
एरिया अंडर द कर्व.
हाँ, एरिया अंडर द कर्व आएगा ना, वो वेलोसिटी में आएगा. इसके एरिया निकाल के क्या करोगे, इसका एरिया क्या रिप्रेजेंट करेगा आपको, इसका एरिया अगर इंटीग्रेट करोगे s into t तो क्या मिलेगा आपको,
कुछ नहीं आएगा इसका.
हाँ ठीक है. नेक्स्ट क्या आएगा अभी, नेक्स्ट कौन सा st के बाद,
VT.
VT.
VT. अभी VT डायग्राम देखते क्या है, ओके. So now let us consider VT diagram. Let's say I take any random figure. This is my V. X-axis fix रहने वाला है हमेशा, okay. Now let us take any curve. Again I consider, let's say, two intervals here. Let's say this is T1. Let's say this is T2. Okay. Now just tell me the use of this. Let's see use of this VT curve, okay. What I can do here is, see here, पहला चीज मुझे क्या पता है, यहाँ पे y axis represent कर रहा है v and x axis क्या represent कर रहा है t. So if I consider a slope, okay, that will be dv by dt, and I know that this dv by dt is nothing but what, acceleration, right now. So this can be written as v2 minus v1 upon t2 minus t1, right. This is what slope, am I correct? Hello. तो पहला इसका यूज क्या हो गया, the slope of the VT curve will give you the slope of VT curve between any two intervals, okay, any two intervals will give you the acceleration of a particle, right. ये पहला हो गया, correct.
Yes.
Hello. Now second thing, see here, अगर अभी मैं यहाँ पे let's say in between this I try to, let's say, अगर मैं यहाँ पे फिर से मैं अगर वही एनालिसिस करूँ, ठीक है, क्या एक्सीलरेशन के बारे में जानना चाहूँ कि पॉजिटिव कहाँ पे होगा, नेगेटिव कहाँ पे होगा, फिर से मैं टेंजेंट ड्रॉ कर सकता हूँ यहाँ पे, ओके, एंड आई विल find that a will be here always, dv by dt will be always greater than 0 at this point, okay, because slope is what? Increasing slope. Similarly here a will be dv by dt, okay, I will find that it is what? Going downwards. So slope is what? Less than 0, that is decreasing slope, so that will be negative here, correct? ये दूसरा हो गया, मैं इसका डायरेक्शन पता कर सकता हूँ एक्सेलरेशन का, ओके. थर्ड थिंग इज व्हाट? कैन यू टेल मी? If I consider, let's say, some strip here, okay, if I consider some strip here, okay, of let's say thickness इसका है dt, okay, let's say this is dt, okay, if I consider some strip of thickness p, okay, and this represents what? V, correct? This height will represent what? V, na? This is V and this is what? P, okay. So area of this strip will be what? Hello? Area of this strip will be what? Yes? Hello?
Integration of d
Integration.
V into D, V into T, na? V into dt. Area of this strip will be V into T. Let's say this is elemental area. Similarly, if I want to find out the total area under this curve, okay, the total area covered by this curve which is given, so how can I find? This I can integrate, na? This V into T dt, right? Between these two time intervals T1 and T2. Am I correct? अगर T1 से लेके T2 तक मैंने इसको पूरा इंटीग्रेट कर दिया, तो I will get the total area, correct? Am I correct or not?
Yes, sir.
And what does this represent? Can you tell me? V into dt. If I substitute,
Displacement.
yeah, this will represent the displacement. So area under VT curve will give you the change in positions, not displacement. It will give you the change in, or you can say displacement, or you can say change in displacement. Okay, sometimes it is called a change in positions mostly. Okay, so it will give you the displacement. That is nothing but the change in position of the particle. Change in position of the particle, okay, between any two intervals, okay, T1 and T2, let's say. Are you getting me? So mathematically, if I want to write this, how I can write? I can write the change in the position, that is delta x, is nothing but given by the area under VT curve, okay, that is x final minus x initial is equal to area, correct? So that means if I know the initial position of the particle, I can find out x final ultimately by using this formula, that is xi plus a. Am I clear? Hello?
Yes, sir.
So this is what the VT curve. और कुछ कर सकते हैं क्या VT curve में? VT curve का स्लोप भी कंसीडर किया, स्लोप हमें एक्सेलरेशन मिल रहा है स्लोप से, एरिया भी कंसीडर करके देखा, एरिया से हमको चेंज इन पोजीशन मिल गया. अभी और कुछ है क्या बाकी इसमें? हेलो? तो यू हैव टू रिमेम्बर VT कर्व का क्या है यहाँ पे यूज, दो यूज है. पहला आप यू कैन, इफ यू know the VT curve, okay, if you have VT curve with you, you can determine the acceleration of the particle as well as the change in the position of the particle. तो अगर क्वेश्चन में VT कर्व दिया है और आपको पूछा है draw the AT curve and XT curve, तो you can draw, okay, by the calculations. Now next is what? Yes, AT diagram, correct na? Hello?
Yes, sir.
Using AT diagram, what we can calculate? Can you tell me? Using AT
Velocity.
diagram, हाँ, AT diagram से हम लोग velocity निकाल सकते हैं, और क्या निकाल सकते हैं? Position निकाल सकते हैं, displacement.
Displacement निकाल सकते. Position कैसे सर?
Position, change in positions. Displacement means change in position, na? First picture.
डिस्प्लेसमेंट कर सकते हैं ना, एग्जैक्ट पोजीशन नहीं निकाल पाए.
Exact nahi, change in positions. And change in position itself is a displacement, na? Right, na? Hello?
हाँ, यस सर, यस सर.
So once you get this AT, अगर आपके पास AT curve है, तो you can calculate the VT curve. Correct ना? VT curve निकाल सकते हो ना? VT निकाल सकते हो. ये VT आ गया तो VT से ST निकाल सकते हो. Correct? बराबर कि नहीं?
Sir.
But suppose if you know AT curve, can you directly calculate the ST curve without calculating this VT curve? The answer is
डिस्प्लेसमेंट मिल
yes.
जाएगा, हाँ, डिस्प्लेसमेंट मिल जाएगा तो हो
Yes.
सकता है.
You can either go like this. You can first calculate velocity using acceleration time diagram and then calculate the displacement using VT diagram. Or you can also calculate directly this displacement using the acceleration time diagram. We are going to see both. Okay, how? So let's see. So this is what application of AT curve. Okay, AT curve. तो AT curve में पहले मैं एक random figure बनाता हूँ यहाँ पे. Let's say this is my T. This is my A. Okay. ठीक है. Let's say this is any random curve. Okay. Let's say this is time interval T. Let's say this is T2. Okay. And again I can check this slope. Okay. तो पहला क्या है यहाँ पे यूज, हाँ, स्लोप क्या हो जाएगा यहाँ पे, y axis is a and x axis is time. That means a2 minus a1 upon t2 minus t1. What this parameter is called?
velocity.
Hello. This is called jerk. What? Jerk. So first I can calculate jerk using this slope of this AT curve. Okay. Next thing is what? I can consider any strip in between this area randomly. Okay, of thickness, let's say delta t. This is my strip. Okay. Let's say dt. Okay. If I consider the area of this strip, this is elemental area, huh? Not total area. Elemental area of the strip, that will be A into dt. Okay. So total area, how I will get total area under the AT curve?
ADT.
I can integrate from T1 to T2, which is this, covered by this, correct na? This will be A into dt. And what is this? This is nothing but the velocity, correct? Or change in velocity, which is correct. Hello. This will give you the change in velocity. Yes, this will give you the change in velocity because it is a two time intervals. Okay, change in velocity between any two time intervals. Okay, correct. So here you can write delta V is equal to area under AT curve. Okay, so V final is equal to V initial plus area of AT diagram. Correct. So if you know the initial velocity, you can find out the final velocity using AT curve. Correct. The positive area will indicate the what increase in the velocity, and the negative area will indicate the decrease in velocity. Correct, no? Hello. Positive area
Yes, sir.
है तो increase in velocity, negative area है तो decrease in velocity. Correct.
Yes, sir.
On the next question, my next question, see, once you got this V, okay, velocity, you can plot the VT diagram from this calculation. And once you plot the VT diagram, then from VT diagram you can get the XT diagram, right? Or ST diagram, whatever you are calling. Okay, but this is the one thing which is possible. But I'm asking you, let's say I want, this is my AT curve. Okay, this is my AT curve. Okay, let's say any time interval. अभी जो मैंने draw किया था वही diagram. Let's okay, and I want directly to get ST curve. Can I do this using AT curve?
सर VC को बनाना पड़ेगा.
हाँ बोलो. So for this, what you have there, you can calculate. Okay, again what you need to do here. Okay, to find out the final positions. Okay, using, or if you want to find out final displacement or final x, whatever you are calling. Okay, this can be written as xf is equal to initial position of the particle plus vi into t. Okay, you need to take the moment of this area about the centroidal point. Let's say the centroidal point of this area is here. Okay, let's say this is what tg. Okay, tg is what centroid of the area, and let's say we want to find out. Okay, अभी आपको समझो यहाँ पे 0 से स्टार्ट हुआ आपका टाइम इंटरवल. ओके, लेट्स से दिस इज योर t1 t2 t3. ओके, लेट्स से t तक है. आपको 0 से t के इंटरवल में ठीक है कोई भी पॉइंट पे पूछ सकता है. लेट्स से इसका सेंट्रोइड जो है यहाँ पे लेट्स से tg पे है. ओके, तो बिटवीन एनी टाइम इंटरवल, ओके, between any time interval 0 to t, you can calculate the change in positions if you can locate the centroid of this area by using the area moment method. And that can be formulated as xi plus vit into area under AT curve. Okay, from 0 to t into what? T minus t into g. Okay, what is this t minus t into g? Okay, that is nothing but the distance. Okay, distance of centroid, or distance of centroid of area measured from time t along what? X axis. Are you getting me? This will see in the numerical when we solve, and both the results will be same. The results which we get from here, okay, after v to x, and which you get from here directly, that both will same. We solve the same numerical with both the methods, and we'll check whether we are getting the same value or not. Are you getting me?
सर आप ये टीजी वाला पार्ट फिर से एक्सप्लेन कर सकते हो?
Yes, of course. See, for example, let's say your AT is something like this. Let's say, okay, let's say your AT curve is triangle. Okay, this triangle. Okay, let's say your AT curve belongs to this triangular area. Okay, are you getting me? Hello. Hello.
Yes sir.
And let's say this is 0 to t. Okay, time interval. It can be anything, 3 seconds, 4 seconds, 5 seconds, anything. Okay. Now what you need to do if you want to calculate, okay, this is my AT curve. Okay, let's say, for example, so if I want to calculate the change in positions, what formula I have? Xi plus, okay, area under this AT curve. What will be the area? Let's say this is the base. This is the base B. This is the height H. So area of this will be half into base into height, right? Am I correct? Hello.
Yes sir.
According to formula, what is the formula? Formula is xi plus vi into t plus area under AT curve, okay, into t minus tg, okay. right ना? So as per here xi, okay, xi means initial positions at the start. It may be or may not be 0, okay. It will be specified in the example problem में दिया होगा, specified होगा 0 है कि नहीं है, xi, okay, plus vi, again vi into t, okay, t जो भी रहेगा वहाँ पे आप सब्स्टिट्यूट करोगे, and area of this particular is what, figure is what, half into base into height, correct ना? Hello,
Yes.
hello.
Yes, sir.
Now your doubt is what is t minus tg, okay. Now let's say this is base b na, so what is that t minus tg? T minus tg is nothing but you can read distance of centroid of that area measured from the time t along the x-axis. So that will be the distance you will measure from here, okay, to the centroid. Let's say centroid is here, you know that centroid is what, at 1/3 from the base, and is what, 2/3 from the base. So it will be 2/3 from the base, it will be 1/3 from the 2/3 from the apex and 1/3 from the base. So this distance measured from the t, okay. So t is what, here, t is here. It will be measured from here to the centroid. Centroid कहाँ पे आएगा, यहाँ पे आएगा. तो ये वाला जो distance है, this distance, this is what, t minus tg. That will come here. That will be 2. Sorry, that will be how much here? That will be b by 3. Are you getting? Hello?
Sir,
Hello?
hello, sir.
हाँ बोलो.
Sir, so basically, if we have to find the velocities, so we have to directly integrate the area into time graph. And if we have to calculate the displacement, then you have to use this formula, na?
See, if you have AT curve, you can integrate and you can get VT. Then once you got VT, you can integrate, you can get ST or XT, whatever you are calling. Okay. Okay, this is the conventional method. ये मैंने क्यों बताया? It is a alternative. You can directly get AT to XT curve without finding VT. Okay, when you need to find XT curve without finding VT curve, you have to follow this procedure. That is area movement procedure. Okay.
Okay, sir.
Yes, sir.
Yeah. So you have two options. Either you can go from AT to VT, then VT to XT, or you can go directly from AT to XT. Okay. तो अगर प्रॉब्लम के अंदर कुछ भी नहीं दिया है, तो you can follow any step. But if it is specified, find out XT without finding out the VT, then you have to follow the area movement procedure. Okay. Am I clear to you?
सर मोमेंट ऑफ एरिया क्यों ले रहे हैं पर?
That is not the part of your discussion here, because that is not asked in the exam. Okay. That is what actually the whole answer derivation part. Okay, वो आपको पूछेगा नहीं. इसका सिर्फ application है आपको.
Sir means that
अभी
only that
area,
you have to remember this formula by default.
हाँ, moment क्यों दे रहे हैं? Means see, this is what ये जो position है ना, position हमको direct 80 से निकालना है, ठीक है? और 80 को इंटीग्रेट किया तो VT आता है, राइट ना? बट हमको 80 से डायरेक्ट XT पे आना है, तो कैसे आएंगे? हेलो,
समझा सर.
Yes, sir.
तो दैट इज व्हाट द मैथमेटिकल इंटरप्रिटेशंस, ओके, उसके पीछे है. तो ये आपको सिर्फ डिराइव नहीं करने को आप पूछेगा, ये आपको सिर्फ अप्लाई करने के लिए पूछेगा, ठीक है? तो यू हैव टू जस्ट कीप इन माइंड दिस फॉर्म. यहाँ तक क्लियर है सबको? मोशन कर्व्स के बारे में क्या है, कुछ पूछना है कुछ? हेलो, so these are my motion curves, okay, commonly used motion curve ST, VT and AT curves. Okay, यहाँ तक आपको समझना बहुत इंपॉर्टेंट है. अगर ये नहीं समझा है तो फिर आपको प्रॉब्लम्स में दिक्कत आएगी। इसके अलावा और एक चीज है जो अभी मैं आपको बताऊंगा, वो भी आपको ध्यान में रखना, दैट इज द म्यूचुअल ग्राफ्स। दैट आई थिंक यू नो, मैथमेटिकली आपने, मैथमेटिक्स जिसका स्ट्रांग है वो बता देगा। Any doubts still here?
No, sir.
Okay. So now let's say consider you have uniform motion. Okay, uniform motion. That means uniform motion means velocity as constant. Okay, uniform motion means what? Velocity is constant. Tell me, if velocity is constant, my VT curve will be, hello, VT curve will be what?
Linear. So constant.
Constant.
Straight
That means it
line.
is straight
Horizontal
line.
Straight
That is
line.
straight line, correct? If my VT curve is straight line, what would be my acceleration curve?
Linear curve.
Straight line from origin.
What would be my XT curve? Can you tell? See, मैंने एक बताया था अभी, अगर displacement is a polynomial of n degree, okay, so then this will be n minus 1, a will be n minus 2, correct? Similarly, you can go reverse, no? Acceleration is n, then what? Velocity will be n plus 1 and acceleration will be n plus 2, correct? If your acceleration is of polynomial of degree n, polynomial of degree n, velocity curve will be representing a polynomial of degree n plus 1 and displacement will be representing a polynomial of degree n plus 2, correct? So I am having Vt here. Okay, when I will differentiate this, I will get At. That means I will get zero curve. ठीक ना? Correct ना? So here it will be zero acceleration. Correct? This is my At. Correct? This is my Vt. Am I correct? Hello?
Yes, sir.
And my St will be?
Linear curve.
It will be parabolic.
Parabolic.
Linear.
Sorry, linear.
This will be what? This is
Sir,
this
origin से ना.
Yeah. Sorry. I was studying it was
that will be
linear
by,
origin.
yeah, that will be origin से होगा. If suppose any y-intercept is given, तो ये यहाँ से आ जाएगा. समझ में आया ना? Are you getting me? This is what St curve. Similarly, you can draw for various types of motions. Okay, if let's say UAM, uniform acceleration motion. Okay, uniform acceleration motion के केस में क्या होगा? I know the acceleration. Okay, my acceleration is uniform. That means A is what? Constant. Correct? Hello. Then I can have
Yes,
the
sir.
velocity curve. Velocity curve will be this one. Okay, and plus 1, that is, let's say like this. Correct, Anna?
Yes, sir.
Hello. And my
Yes.
this is Vt. This is At. My St will be what?
Parabolic curve.
पैराबोलिक. बट पैराबोलिक का भी देखो, पैराबोलिक में ऐसा भी होता है और ऐसा भी होता है, कॉन्केव अपवर्ड्स, कॉन्केव डाउनवर्ड्स. तो ये कैसा पता करेंगे अभी? यू नीड टू चेक द स्लोप. You need to check the slope. So always go for the slope. Okay. So slope is what measured anti-clockwise always with respect to positive x. That is theta. You can see here theta is not varying. Okay. Hello.
Yes, sir.
Yes.
Just a moment. Here you can see. Okay. ये जो है आपका, यहाँ पे ये जो कर्व है, okay, this will be what? ये linear है, इतना तो पता है, this is of degree n, this is of degree 0. Now it will be parabola, so it will be it can be either like this or this, correct? So there are, see, I will give you some possibilities. Out of that possibilities you will never get the curves, okay? तो इस केस में क्या होगा actually, if you see this curve, okay, this one, here you are getting constant slope, correct? Hello?
Yes, sir.
Constant, but it is what? Positive slope, correct na? Constant but positive slope. Am I correct?
Yes, sir.
तो इसका मतलब यहाँ पे क्या होना चाहिए, ये जब ये कांस्टेंट स्लोप है तो अपना जो यहाँ पे ये जो कर्व आना चाहिए डिग्री n का, डिग्री n इज इक्वल टू 2 आना चाहिए, पैराबोलिक आना चाहिए। तो ये ऐसा आना चाहिए या ऐसा आना चाहिए? हाउ इज इट प्रेडिक्ट? Since it is upward, right? Since it is upward, it is rising in the upward direction, correct? Like this, in the positive directions. That's why this will be concave upwards, okay? So this will be like this, okay? That will be of degree n2. Similarly, अगर suppose ये क्या होता था आपका, one thing you have to note here, just a moment. Hello?
Yes, sir.
These points you have to keep in mind while drawing the curves, okay? This is if you are 80, I'm giving you all possibilities. If this is your 80, let's say, okay, if this is your 80, okay, your VT will be parabolic, correct? Parabolic, but see, this is what? Increasing in the positive direction, correct? The slope is increasing in the positive directions. अगर आप ये measure करो यहाँ पे values, so this is increasing in the positive directions, okay? But it will have some constant value, okay? So this should also be increasing in the positive direction. So it will have like this. This will be VT. Okay, if you see here, this will be anti-clockwise and increasing in the positive direction. So you will have anti-clockwise curve. Okay, are you getting me? And once you have VT as a parabola, so ST will be what? QB. Okay, cubic. Okay, this will be of degree 3. Okay, this will be ST. Am I clear? Similarly,
Yes,
if you
sir.
have the AT curve, ये पूरा कर्व्स के बारे में स्लोप और मैथमेटिक्स का है पूरा, तो ये आपको थोड़ा सा पता होगा, ध्यान में आना चाहिए, इमेजिन करते आना चाहिए। ओके, दिस इज 80, तो VT कैसा होगा अभी बताओ? नाउ यू कैन सी हियर अगेन, दिस इज व्हाट? पॉजिटिव, बट इट इज व्हाट? डिक्रीजिंग इन द पॉजिटिव डायरेक्शन, राइट ना? इट इज व्हाट? डिक्रीजिंग इन द पॉजिटिव डायरेक्शन। तो माय VT विल बी, यस,
Downward parallel.
Convex parabolic.
right this, okay, concave downwards, so it should be decreasing in the downward direction, so it is clockwise, okay? Similarly, let's say you have like this, okay, if you have like this, let's say it is what? Increasing in the negative directions, okay? This is, you can see, increasing in the negative directions. If you measure the slope here, okay, so you will find theta is variable and theta is increasing in the negative directions. So for this type of curve, what should be the nature of the graph of the curve? Hello? इसमें कैसा आएगा?
Same.
हाँ, इसमें कैसा आएगा? This is what? This is decreasing. This is deceleration.
Hyperbola.
This is
Same
deceleration.
आएगा ना?
Deceleration है ये. Deceleration है और increasing.
Hyperbola होगा ना?
Hyperbola कैसे आएगा?
Parabolic. Downward
VT
parabolic.
curve है. VT curve है ना ये. ये 80 है ना आपका. 80 is what? Linear. तो ये parabolic आएगा ना, और parabolic कैसा आएगा? Like this, correct? This is what? Slope
Yeah.
increasing in the negative directions, correct? just mark the slope and check decrease हो रहा है कि increase हो रहा है. Okay. Similarly, if you have suppose like this, it is what? ये कैसा है? Decreasing in the negative directions, right? This is your VT. Oh, sorry, AT. Let's say. तो VT will be कैसा होगा यहाँ पे? Yes. हेलो. VT कैसा होगा यहाँ पे?
Parabolic downwards.
Yeah, this is what negative, na?
Parabolic downward.
This is decreasing in the negative direction, so this will also be decreasing in the negative directions. Correct. So these are the natures of the graphs. Some standard graphs you can keep in mind. Okay, you can draw and think. Okay, so that you should know at least. Okay. Next time when we'll solve the problems, we'll see some more
तेरे
illustrations.
पर लास्ट स्लाइड वापस दिखाना.
Okay.
Yes, sir, done.
So on the basis of that, if suppose now I take variable motion, okay, variable motion, variable acceleration motion. So here I know this acceleration would not be constant. Okay. So acceleration not constant means what? ये मेरा A हो गया, ये मेरा T हो गया. So let's say my acceleration is varying like this. Let's say for example, okay, linearly varying. Okay. अभी मुझे बताओ VT का क्या होगा?
Upwards parabolic.
Yes, concave upward because it is increasing in the positive direction. So it will be, okay? This will be n is equal to 2, and ST will be
Cubic upward.
Cubic.
yes cubic. So this will be degree n is equal to 3. Okay, this is cubic. So I hope it is clear to you. Okay. Okay.
So can you go to the previous slide? Just a second, sir.
हो गया.
Yes.
Now, in addition to this, one more thing you need to remember. Okay, let's say for example, suppose आपका AT का अभी ऐसा था, ठीक है? तो आपका जो भी है ये ग्राफ कैसा आता है इसका VT का, you know that ना, ये आपको पता है, इस VT you know ना. Now you have to calculate the ST from VT ना, so you need to find out an area ना, area under this curve VT है ना. So for that you need to remember the area का formula. So for that purpose, let's say if I have this type of parabola, okay, this type of parabola, okay. This is my shaded portion. I want to find area under this curve, okay. It is, let's say, curve of polynomial, okay, of, or you can say degree n, okay. So what will be the formula for area here? Area I can calculate by using this formula. If it is, if the base is A and the height is B, okay, I can apply this formula AB by n plus 1, correct? Right now, let's say for example, if it is of degree n is equal to 2, let's say it is parabola. So area will be what? 1/3 of AB, correct? Am I clear? Hello?
Yes,
सर
sir.
मतलब डिग्री 1 होता तो ट्रायंगल बन जाता ना.
हाँ, ट्रायंगल हो जाता तो वो 1/2 AB हो जाता. So this is what general formula. You can apply anywhere
Yes, sir.
for degree n. Similarly, if you have curve like this, उसका ही split portion लिया मैंने बचा हुआ, ठीक है? अगर आप ये देखोगे ये ऊपर वाला, ठीक है, ये वाला, है ना? ये वाला, ये वाला पोर्शन लिया बचा हुआ ऊपर, अब उसको यहाँ पे आइसोलेट करके ड्रॉ किया, ठीक है? मतलब ये वाला शेडेड पोर्शन आपको समझ में आ रहा होगा, आई थिंक. This is my A,
Yes.
this is my A and this is my B. तो इसका एरिया क्या होगा? सिंपली जो बचा हुआ है 1 में से 1/3
Same
गया तो
होगा
कितना
ना?
बचा? सेम कैसे होगा?
TB
This
upon
cover,
3 होगा.
this covered portion is 1/3 ना, तो this
Yes,
part
third,
remaining is 2/3 ना, so this will be 2/3 ना. So that I can write in general way NAB times, if it is 1, total is n ना, तो n में से 1 निकाल दिया मैंने, तो बचा कितना अभी? ठीक है, यहाँ पे मैंने ये जो है उसका डिग्री n है ना, nth पॉलिनोमियल है, तो यहाँ पे तो इसका मैंने डिग्री कंसिडर नहीं किया, अभी यहाँ पे ये कंसिडर होगा, that will be n plus 1. Okay, for example, if you have degree n is equal to 2, so area for this will be 2/3 of AB. Are you getting me? So if you have a convex upward type of parabola, this you can write, okay, to find out the area, and if you have convex downward, you can apply this formula. Okay, is it clear? Hello.
Yes, sir.
Yes, sir.
So this is all about for today. I hope you understood everything. Next time we'll meet and we'll take the numericals. Then your idea will be more clear. Okay, if you have any doubt, you can ask for today's session. तो आज सारा बेसिक्स हुआ. Okay. नेक्स्ट टाइम हम लोग जब भी मिलेंगे तो न्यूमेरिकल सॉल्व करेंगे. ओके, तो उसमें और भी ज्यादा आपको जो भी नहीं समझ होगा वो अच्छे से समझ में हो जाएगा. ठीक है, कुछ पूछना है आपको? हेलो, और
सर आज का ये फाइल शेयर कर सकते हैं?
ये आपको रिकॉर्डिंग देखना पड़ेगा और इसके अलावा कोई ऑप्शन नहीं है. एंड यू कैन रेफर द बुक्स व्हिच आई हैव रिकमेंडेड फॉर यू. हेलो.
Okay, sir.
You can refer the recording anytime and refer the books. So shall I stop? Hello. Or you want to ask anything? Attendance लिया मैंने. You want to ask anything?
No. No, sir, no doubt.
So again we are meeting tomorrow at 3:30, na, I think. Hello. Hello.
Yes.
So tomorrow we'll solve the numericals, okay? तो जब भी न्यूमेरिकल सॉल्व करेंगे तो ज़्यादा प्रैक्टिकल अंडरस्टैंडिंग आ जाएगा आपको. जो भी थोड़ा बहुत डाउट होगा आपको वो सब क्लियर हो जाएगा कल. ठीक है, तो ये रिवाइज करके आओ थोड़ा अगले लेक्चर में. ओके.
Okay, sir.
Okay, so bye, take care. Okay, now I will end the meeting. You can leave. Okay, thank you.
Thank you, sir.